Martin Neumann, es el director del área de productos conectados y herramientas del grupo Fischer, que nos va a hablar del futuro de los sensores aplicados al mundo de los anclajes y todo el impacto que tiene esto en la seguridad estructural. Martin, adelante.
All right. Thank you for your attention. Thank you for the interest in this topic. My name is Martin Neumann, and I want to show you today an innovation we have at Fischer. I want to talk about sensor-integrated fasteners. I want to talk about reduction of costs when it comes to maintenance and inspections. But before I do that, before I talk about fasteners, I want to talk about sensors. Why should you even bother using sensors? And I want to give you one example. Me being a German, of course, car is a good example, and I guess you're all driving a car. And the most important part of a car and the car's safety to operate on a street are its tires. Because the tires are the only part where the car is touching the street. And the tires have a predefined pressure. And only if the pressure is reached in a certain limit, then the car is safe to operate. So what you actually have to do before driving your car is you should go around your car, check the pressure of each tire to see if the pressure is in the right limit, and only then you should start driving through Barcelona. But you're not doing that. You're not walking around your car every day before you drive. Why? Well, you have pressure sensors in your tires. And those pressure sensors, they communicate with your computer. And then you see in your car dashboard the pressure of each tire. They notify you if the pressure is too high or if the pressure is too low, and they do it in a very efficient way. So the sensors give you the transparency of a very crucial information, so you have the safety you need, and you get it very, very efficient. So one way where sensors make your life easier, and for tires, I think we all understand that, because tires are made of rubber, there's leakage. But what about fixings? Aren't they made for a lifetime? Why should you monitor fixings? Well, for two reasons. One reason is the short process of installation, and the other reason is the long process of operation. Let's start with the installation. You know, a screw has a predefined torque, so you apply the torque, and this torque translates into the force, into the preload of a fixing. But this is not a one-to-one translation. There is a loss of force due to friction in the head, friction in the nut, friction in the thread itself. So of the 100% torque you apply, only 10 to 20% of the force you apply actually results in preload in the fixing itself. So to ensure that the defined preload is there and that the forces are big enough, there is a lot of safety factors. And there's a huge variety of forces in the fixing itself, depending on how fast you are applying the torque. So there's a huge variation, and usually those fixings tend to be a lot bigger than they actually need to be. A lot of resources might be wasted here just to ensure its safety. But the more interesting point is the time during which a fixing in a building or a big structure is in operation, because over time there is a loss of tension. And over time you might not really know if the predefined preload force is actually still there, if it's still secure, if the fixing is still tight. And not knowing if a fixing is secure is a problem, especially when it comes to big structures and big buildings, roller coaster, roof constellations in stadiums, or offshore platforms. If you don't know what's going on there, that's safety critical, that's dangerous. So what you can do is, well, you could walk around your structure, check every fixing yourself. Or you use sensors. At critical points, you use a sensor, and the sensors communicate the information of the forces in the fixing to a central system. They show it to you. They show if the forces are within a certain area and everything is safe. They give you the information, the transparency you need to ensure the safety, and they do it in a very efficient way. And that is why we have construction monitoring, and that is exactly what we do. We look at structures, at buildings, which have very high safety standards, which are difficult to access, which have high maintenance and inspection needs, and we offer a solution. We have sensor-integrated fasteners, cloud communication and dashboards so that we can give our customers, our end users, the information they need to ensure its safety. And this way of digitalization, this way of innovation came quite naturally to us because we as Fischer, and you know that, we are the expert when it comes to fixings. We have decades of experience. We have thousands of customers where we interact with and get the idea what they need. And we have high quality products. And me and the department of connected products, well, we are the expert when it comes to sensors. We're the expert when it comes to software development, and we know the communication protocols on the data safety. So if you combine the knowledge of Fischer and our digitalization spirit, construction monitoring is a result. This is what we do now. This is what we offer as Fischer, construction monitoring sensor-integrated fasteners. And we have a bunch of products for this. Different products for different application. There's the sensor disc, which Professor Bergmeister already mentioned, which you can apply in any kind of fixing to these forces. There's our sensor anchor, which is an anchor, a chemical anchor, which you can use when you want to fix something in concrete, and we can measure the forces. And there's our newest product, the sensor bolt, which is a high-strength screw with a sensor and a transmission module for remote monitoring. And since we talked a lot about concrete today, I don't want to continue talking about concrete. I want to talk, for example, about the steel connection, steel constructions, and the connections we need there. So the sensor bolt, I'm the first to use a product today on stage, so there's a product. This is the sensor bolt. This is a high-strength screw. And the only thing we did, we modified the top. We integrated sensors on the head of the screw, very small. We didn't weaken the screw. The screw is still as strong as a normal construction bolt, but we have the sensors here, and there's no battery included, so what you can do is you just take a smartphone with NFC, you tap it, and then you can read out the preload force in kilonewton. But you need to tap it with a smartphone, so you need to be there. So what is the point, actually? You can just go with a torque wrench. Well, the second part is our communication module. In here, there's a battery. In here, there's a microcontroller, and there is an antenna. And when you attach it on the sensor bolt, now we have remote monitoring. Every 1 minute, every hour, once a day, the module reads out the data and transmits it via LoRaWAN to the nearest gateway, and from there to the cloud. So here we have an intelligent fixing solution, which is rather simple. The battery of the node lasts up to 5 years if you measure every 2 hours. If you measure once a day, it lasts 15, 20 years. And by doing that, we can offer monitoring of fixing solutions in a very simple way. And you don't have to throw it away, because if the battery is empty, you just open it and change the battery. And this product gives you the transparency you need. And I've shown this picture quite often right now, and I guess you know why. Well, this is where we have sensor bolts installed at an offshore platform, and we monitor the forces here so that the maintenance crew, who used to be flying in with a helicopter, checking the screw connections, they have a boat underneath in case something falls down, and this is quite costly. So they're using our solution, the sensor bolt, to monitor it, and we are not only offering the hardware, we are also offering a secure data communication, we're offering a cloud infrastructure and the dashboards to visualize it all. But we are not only having offshore platforms as use cases. Our solution is for every fixing which is safety critical and difficult to get to. We have it installed in the North Sea, we have it installed in Austria in the mountains when it comes to a radio tower. Customers are also interested to have indoor cranes monitored and fixing there, or the stadium roof I showed you before, as well as the theme park. So there are different use cases, there are different appliances, and always when they're safety critical and difficult to get to, customers come to us and ask for our monitoring solution. And when we install it at the customer side, we always support them as well. So they're getting a dashboard, they're getting the data, and we can help them to interpret the data, so they are not getting only the products from Fischer, but as you know us, we are a solution provider. So we are giving everything the customer needs from one hand to support them to make their maintenance processes, their inspections as easy as possible, and to give them the insights they need to maybe in the future build a little smaller, save resources, save money, and reduce their maintenance efforts. And I want to show you now a few examples of the data, of the transparency we gave to customers. And I want to start with tightening. So here are two graphs, two sensor bolts. And you see in green, this is the force level, and you see in blue, that is the temperature. And you see the temperature goes up and down and up and down, and that is the cycle of day and night. And at the bottom graph, you see the green line, it jumps to roughly 28 kilonewtons, and it remains that way. And at the top graph, you see that it jumps to, well, 17 kilonewtons, and then it jumps to 28. And that was the case because the same person with the same tool installed both bolts, and after checking the data, they realized that the first bolt is not tightened enough. 40% less preload in the product, but they did it exactly the same way. So after checking the data, they retightened it and then ensured that everything is safe. And this information you only get if you have sensors in place, because you can't see a screw is tight enough just by looking at it. You need a torque wrench, or even better, have a sensor in the power and in the force flow. Another example is the loss of preload. I mentioned it. Whenever you have a fixing over time, there's always a slight loss of preload. There's a setting effect. But how big is that effect? Well, in the steel construction, 2 to 3% is okay, but usually it's 5 to 15%. But it would be good to know that in your fixing at a critical point, that this preload force loss is not too big. So here we can see, after 6 months, we lost around 8% of preload. That is okay. That is still within the limits. The structure, the building is still safe to operate. And with this knowledge, you can rest in peace and you don't have to worry and you don't have to go there and check again. So that is the loss of preload force. But what we can also offer to our customers are insights during the operation. So here you see at some point, this was done at an indoor crane, the preload force jumps and then it wiggles a little bit, and we have quite some big impact in the end. Yeah, well, this was an indoor crane during operation. And now for the first time you actually see the forces during operation. You know that the crane is safe, or if there are some problems. And here you see that that is okay, 40 kilonewtons, and that for this particular case, that was still okay. So the owner was happy, the crane is working quite well. And this is some insights you get when you have the sensors. There are other examples. If you have a wind farm and there was a storm, or you have a theme park and there was a storm, or a cable car, is it still safe to operate? Or do you need a maintenance crew to check? Well, you don't need industry climbers anymore if you have sensors in place which can tell you, yes, sure, the forces are still okay, everything is going smooth, don't worry, you can open it. And this is what we want to do. We want to give our customers the insights they need to help them with their decision making, and we want to reduce the efforts they're taking for inspections and maintenance to ensure its safety. And we as Fischer, we are a fixing company, so we started with fixings. But fixings is the start. We have a vision. We want to offer a holistic approach to buildings. We want to have all necessary data in one system. So when you're looking at your bridge, at your structure, at your building, we want to offer you everything you need, give you the transparency you need to make decisions based on safety, and we want to do it in the most efficient way possible by giving you the remote monitoring abilities. This is the future. This is the present. With our sensor bolt, with our digital bolts, we can support you in your projects. So if you have an idea, if you want to know more about it, or if you have a project, contact us as Fischer, go to our website, talk to me afterwards at the coffee break, or get in touch with your Fischer contact here in Spain, and we can help you getting sensors in your fixings and make your life easier. Thank you very much.
Is there any question for Martin? Oh, we'll have him now in the next roundtable. Martin, thank you. Bueno, como decía, gracias por esta visión, en este caso tan aplicada, ¿no?, sobre el papel de la sensorización en la seguridad estructural.